Hello everyone, I'm going to show you how, or really my methodology on how I generate models like this in Minecraft, or some of these over here, as well as like those spheres. Ignore the spheres, those were some tests I was doing. But still, this is really easy. Like, people don't do this, I don't really know why. I mean, yeah, it involves code. Wow, it's so much code. It's like 28 lines of code, if I remember correctly. I mean, lines of code isn't necessarily that great of a measurement when it's literally that small. So here we go. We're just going to jump right into it. I do want a little bit of a warning though for you guys. This is not a tutorial. Unfortunately, I don't really have the time nor the energy nor the care to really make this a proper tutorial unless I think people will actually utilize this knowledge. So I'm doing this as just a video that discusses my methodology. If people actually use this knowledge and talk to me about it in the Discord server, which I'll have linked down below, then yeah, I'll do some actual videos maybe on a second channel. So like one that's dedicated to programming or something. That way we could actually discuss it properly and more in depth there. But anyway, back to the actual generation here. What I do for these very basic generators is I normally generate MC functions. I know it's really stupid just to generate MC functions. I mean, yeah, it's hundreds of thousands of commands. If you turn on the game rule, which would be, was a max command chain length, I think. If you turn on the command rule and set the value to the max, just look up whatever the max is. I think it's like 2.1 billion or something like that. Regardless, you can do a lot of commands. It might be 2.1 million. I don't remember exactly. It's a very large number, to say the least, which means you can generate relatively large builds this way. And especially if you optimize them, they're actually not that big. Here we go. Go to simple.d here. I don't really want to explain what programming language I'm using. I'll have a whole separate video on my second channel specifically dedicated to that. I have a programming channel that I like doing stuff on, and I do some live streams where I program. I don't really talk about it on this channel much because this is a Minecraft channel, obviously. But I want to show just how easy something like this is, like even generating a sphere. This is all the code you really need. Obviously, I could decrease the amount of code, like I could make the code quite a bit less and simplify it even further. But this gives me a lot of flexibility. So for example, with this is adjusting the size. That's basically like the selection. So it's like, hey, I want to generate a sphere that's within, this range, right? Within a certain range, right? So we have our size, which in this case is 30. We're saying the radius of the sphere is 20. Or actually, I think that might not be the radius, but that's beside the point. So we're saying that it's 20 blocks from the center. Yeah, okay, it is the radius. Also, this is from negative 30 to positive 30, as we can see here. So we're going from negative 30 to positive 30. So that's the variable there. So yeah, we're going from negative 30 to positive 30. So we have plenty of room to do our square that's 20 blocks wide. So as the radius. Then we can specify the exact like depth of the build. So we could do like, I want it to be 5 blocks. Let's just do 0 on the first one. And then we can just run it from the terminal. So if I just go to here, cd sphere, we're just gonna, there we go, gen.d. Whenever I run it, we'll get all of those blocks here. Now, for some reason, I did it incorrectly. Oh, yes, we need simple, sorry, simple. Here we are. So now we have the set blocks. That's it. We were just generating that. It's like, oh, that's a lot of blocks. It's like, yeah, it is a lot of blocks. And then from here, we just do sphere.mc function, right? This pipe operator, I don't think it's called pipe, but anyway, we're just sort of passing the output into sphere.mc function. I run it, and it's going to be directly in this file. There it is. It's 19,224 blocks, which realistically, it's like, oh, that's going to be so laggy. And it's like, yeah, I mean, it is laggy if you're placing the blocks like every single frame. Even then, it's actually not even that laggy. It depends on how much RAM you have. I have a lot of RAM, so it's not that bad for me. But again, I mean, yeah, it worked. We also specified the exact thickness we want. If you want it to be exactly 1 block thick, that's a whole separate thing. I'm not going to really discuss that at the moment. But regardless, that's basically it. Like, okay, how does this work? I guess I'll explain that. Do I really need to? Probably not. We're just going from negative 30 x, negative 30 y, negative 30 z. and we're going to positive 30x, positive 30y, and positive 30z. And we're just going, iterating through each one. So it's like, oh, we have, negative 30, right? Then we're going to negative 29. We're going to negative, 28. And let's just say, dot, 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 right? It keeps going. And then once we go, we have, okay, now we're back at negative 30. And maybe we adjust this by like, 1. So now this is 29. And we're literally just iterating through every single block within that area. And then we're just doing a simple check. We're just saying, hey, take the distance, which would be, x squared plus y squared plus z squared. Here we go. Yeah, so we're taking x squared plus y squared plus z squared, and we're saying that that is our current block distance. And realistically, that's our current block distance. Like that's the distance from 0. That's it. That's how you get the distance. And from there, you just check it. Check the distance. Okay, is the distance, in this case, 20 blocks out? And is it within 5 blocks? So we have our inner distance, which would be our 5 here, and we have our outer distance, which would be our 0. And we're just saying, hey, is current block distance greater than inner distance? And is current block distance less than outer distance? If it is, then write the block out. Boom, sphere. That's it. It's really, really not hard to do stuff like this. And you can generate anything you want with this method because it's arbitrary. And with code, you can do all sorts of stuff. And the nice thing is it's MC functions, which means you could do this with particles. You could do this with display blocks. That's something that's actually really fun, is converting a model to display blocks, right? Obviously, if you could actually do more complicated examples and parse like other file formats. You can make your own file format. You can make your own editor. You can do anything with this, right? And that's what's so nice about doing like code. There is no limit to what you can do besides what you can do, right? That's what's so nice about it. Now, if we go to our next example, this is actually going to be parsing the file here. There we go, gen.d. Actually, no, I wanted, what was it? Simple gen. There we go. This is the one that's extra simple, or actually it was supposed to be the one that's extra simple, but I forgot to fix it, but that's beside the point. I'm just going to pretend that doesn't exist. Oh, this is the simple one. Okay, well that's really dumb. I accidentally swapped their names on accident. 1 second. So this is the most basic version of parsing a file. So I'm just going to show you, how to do this yourself. So now we have a monkey here. I just scaled it up. These are the actual dimensions. So if we want to scale it up to like, it's 60-ish blocks tall or something like that, right? We can do that. Now, if we do Control A, we set all the transforms. Actually, you don't want to do that just yet. We want to do a solidify. We're going to set this to be, like 0.5 blocks thick. Now, obviously, it's going to look a little bit messy because we haven't done the actual size yet. Control A, all transforms. There we go. So now it is voxelize. I like to adjust the block so we have a little bit more room. Basically this right here. Now we're going to export. We're going to go to wavefront.obj. We're going to export the selection. No UVs, no normals. And we're apply modifiers and apply transforms. And we're just going to export it now. That was monkey.obj. So that's the thing that we're opening here. So if we actually look at monkey.obj, right, we're going to see inside of here, we have, these comments. We also have Suzanne, that's the name of the thing. We could also use this to store information if we really wanted to. We also have, V, this is for vertice. Now, if I actually go look at this, each one of these things here, that's a vertice right there. There's a vertice here, there's a vertice here. Each of these connection points are vertices, and those roughly lie on blocks, or basically exactly lie on blocks, almost exactly. It's not perfect because it's not designed to be, right? This is not really meant to be what it is, if that makes sense. I'm sort of cheating, if that makes sense, by doing it in Blender this way. But regardless, let me grab one of these lines. Let's go back to simple gen.d. In this case, all I'm doing is I'm just going to open the file, right? We're opening it, we're reading it. We're saying, hey, on every single line, or basically while the file is not at the end. So if we ever hit the end of the file, this will cause it to, stop. So F, in this case, this is our file, end of file. So if we're at the end of the file, in this case, if we're not at the end of the file, then we're going to continue reading a line. So we're going to read the line, we're going to store it inside of line. If the line length is greater than 5, which basically this is always greater than 5. I just wanted to make sure that there was no comments or nothing that was like too obnoxious that I needed to remove. So if it's greater than 5, the length, then we're going to also check to see if the first two characters are equal to v and equal to space. If it is equal to v and space, then we're going to parse the line. Now we can actually split this into multiple parts just to make it a little bit easier to read in this case. But it's pretty much just this. We have our line. We're going to cut off the first two characters and we're going to cut off the last character, because if we go over down to the bottom here, there is a new line character, which you can't really see, it's invisible. So we're going to remove that by subtracting 1 from there. We're also going to subtract 2 from the beginning. So 1, 2. And this is what we're left with at this point right here. Now we're going to split on space. So in this case, we're going to go to our space. We're going to split, go to space. We're going to split. Then from there, we're going to map on every single one. In this case, we're just taking it and we're going to remove 7 characters from the n. So we're going to go to the n, and then we're going to do 1, 2, 3, 4, 5, 6, 7. Again, go to the end, 1, 2, 3, 4, 5, 6, 7. Go to the end. Again on this next one, 1, 2, 3, 4, 5, 6, 7. And then we're going to join with a tilde, which in this case will look like that. We're doing our join and then a tilde. Now we need an extra tilde at the beginning here, which would be this. So now we just joined it up. We have all that. Now we have this, and we're going to insert it inside of our set block. In this case, we have our set block. We're inserting it here, and we also insert our material there. And that is it. Now, whenever I run this, we'll have our monkey.mc function, which is here. And there we have it. This is our generator. Now, if I actually run this, so function cmd monkey, there we go. So now we have a monkey that generated right around our player. It's, like I mentioned, exactly that easy to be able to do something like this. Now, obviously, this is an extremely messy method that has no sort of modifiability. It's not a great way of doing it, but is an extremely small version of the code with almost nothing inside the code. I mean, yeah, technically this is three or four lines of code realistically, but they're all combined into one. That's slightly excessive. It's a bit of a cheap way of decreasing the line count. There's a lot of things that we could do to do that. But either way, it's pretty simple in terms of like what we've done so far. Like this is a pretty simple set of code here. Like I said, it doesn't let us really modify it. If we want to adjust, like, okay, what if we want to expand all the blocks and move them somewhere? What if we want to adjust the blocks by half a block? What if we want to, shrink the model by half a block, right? That's something you might want to be able to do, right? Being able to shrink the model by half a block is actually sort of useful. So you might want to go to the center of the block and then like shrink everything inward. That could fix some of the holes that you can run into, that kind of thing. You also might want to expand it outward. I mean, there's a lot of things you might want to do. Most of the time you would do that in Blender, of course, if you really want to do something specific. Regardless, we're going to go to our next example. So this is gen.d. This is a slightly better way of doing it, where again, we're doing the exact same thing. We're splitting it, we're mapping it, but in this time we are converting it to a float that we actually have our numbers. So now we have our vertice 0, our vertice 1, and our vertice 2. In this case, these are just x, y, and z. So I'm going to change that, set that up actually real quick. So let's just do x like this. Set this to y and set this to z. And there we go. So now we have our x, we have our y, and we have our z. Obviously, it's much better to make your code more readable than it is to remove lines of code. So, like, yeah, technically these lines are taking up extra space, but they're also saving a ton of space at the same time. So this is what I prefer to do normally. And that's basically it. Now, if we rerun this, we'll get the exact same result that we got before. I didn't really change anything. It's just a slightly more flexible way, because obviously we could like invert it if we wanted to. We could multiply the numbers by a negative value. So now we could just say, hey, we want this to be a negative y instead. And now whenever I run it, function cmd, what was it, monkey, right now we end up with a negative version of the model. Right, so I think that's the model we had. Now we just flipped it upside down, right? The fact that we can do that, for example, we can very easily flip the model by multiplying it by a negative value. We could do 2 flips. We could also rotate if we really wanted to, right? You could take every single vertex and rotate them automatically if we want to, like I said, or we could do other transformations. We can really do anything that we want. Now, typically you would want to do that in Blender because we're using Blender to do the remesh, so you'll end up with holes if you go do anything too crazy. But again, like I said, this is extremely easy. Now, the slightly better way of doing this, which I'll show right now, that gets a little bit more complicated, is gen array. I use an array instead of just placing it directly. The reason why is every single block that you place is going to waste space. You really do not want to waste space basically ever. You want to avoid wasted space. And what I mean by wasted space is inside the MC function. Oh, that is sort of large there. How many blocks do we have? Can I sort this? Let's see. There you go. So in this case, it doesn't look like we have any blocks that are necessarily duplicates. But imagine if you have a duplicate block like so here. So if we have 2 blocks that are in the exact same position, that would be a wasted block. That's not great, right? Wasting all that space is a bit of a problem. You don't want to waste block space. You want to make sure that you have the smallest model possible. So you don't really want to be doing anything like this. You want it to be completely the fewest blocks possible, the fewest commands, because we have a limited number of commands, but also the commands cause lag, so you want the fewest number of commands in general. You want to avoid commands as much as possible. So because of that, it's better to have like an array of blocks. So in this case, we have a block array. Instead of having a 3-dimensional array, I have a single 1-dimensional array. It makes it a little bit easier to do comparisons as well as other stuff. And I just have a function that's like, oh, get index. And in this case, we're just able to get the index of the byte array. And I'm opening the monkey obj. We're outputting to monkey obj. So in this case, we have our output file. I didn't show that before. We're writing to it. So we're just opening it and then we're closing it at the end of the scope. We're reading it line by line. If the line starts with v space, then all we're going to do is oh, we're not even using count. So I don't even know why it's there. Anyway, if it's v space, we're going to strip the line and make sure that we remove the first 2 things here. Then we're going to parse the vertice out. Again, I could merge these 2 lines. Doesn't really matter. We're getting the x, y, and z. We're changing them to an integer. Why are we changing it to an integer? Because we're getting, like, again, we're getting the x, y, z coordinate properly, and we're going to put it inside of our get index. So in this case, we're going to get the index into our block array from our x, y, z value. So we're sort of converting a single array of blocks into a 3-dimensional one this way, and we're just going to put the material inside of it. In this case, I have a slightly more advanced material that I'll show you in a moment, but again, the key thing is it's relatively simple. Now, this is the thing that controls materials, that thing I showed you before with the object name. I'm going to use that to change the material. This is parse vertice. This is just export to MC function. We're just going through every single block in the, the 1-dimensional array, basically. And we're going to write it out. Now, actually, there is definitely a better way of doing this. I don't know why I did it this way. I definitely need to fix it, but regardless, yeah, we're just going to write out the entire, array there. Now, the next thing, yes, I need to go to Blender and actually show it. So I need to set the solidify, set the remesh. I'm going to go into edit mode. And again, we're going to set the object view like this. We're going to grab as many of these blocks, the vertices as possible. As you can see, we're grabbing all those vertices. I want to shift and do that again, shift and do that again. This way, basically, we're able to sort of get a light source effectively. We're able to sort of get a shadow for the blocks here. And you can adjust exactly how detailed it is by doing something like this, or yeah, you can basically just adjust it. Now I'm going to right click, we're going to separate by selection. Now we have 2 Suzanne models. This is our original, which is going to be, I guess, black concrete. And we're going to set this one to white. Actually, no, we're going to do gray concrete. That'd be a little bit too bright if it was the other one. We're going to select both models now. So we're going to select both models. We're going to export both of these models as our OBJ file with the monkey there. Now, whenever I read that in, as we'll see inside this model, we have our O at the beginning, which is, guess what, black concrete. If I look for O space, we can also see there's gray concrete. And right below it is more vertices. So we have our vertices here. This is the black concrete vertices and the gray concrete vertices below that. Because it's so consistent, that means we can actually just take that and we can just say, hey, if there's O, just set that as our current material and use that. And because we're keeping track of all of our materials up here, all we got to do at the end is print them out with our materials. Just grab the correct one. And that's basically it. So now if I do run this, we'll get our model. So we have, I believe it was monkey.mc function as the output. Yep. So function monkey.mc function. In this case, I accidentally forgot to move the model. Because we're doing our get index thing, we need all of the positions to actually be positive. So I need to move this in the positive direction. So we're going to move this. I need to select everything. There we go. And then I need to move it over real quick. For some reason, I'm not able to grab both models. There we go. And Y, remove this over here, and we're going to move this above ground, and then we're going to move this over again. There. So now it's completely in the positive direction. We're going to set all transforms again, and we're just going to re-export. Obviously, there's better ways of doing this. The reason why I'm doing it this way is because it uses way less memory. Because if I actually need to adjust the model and get the min and max of all the vertices, it's going to use more RAM as far as I know. And I'm trying to avoid RAM usage, so this is just a much faster way of doing it. So here we go. So we have a monkey again. Apparently I did something slightly wrong. 1 second. Probably set the direction on the thing wrong. Let me actually just look inside of it. This is the kind of thing that you can do, so sort of just adjust. It's like, oh, okay, yeah, see, our X here is actually in the negative, so I believe we have to go over and on this side now. So there we go. It's also relatively easy to fix because whenever we go to export, if you do mess up and there is stuff in the negative, you can actually adjust by setting it to be negative on over there. But I just move it. It makes it a little bit easier to understand whenever you do it that way. Here we go, gen array. We're going to re-export that out. Apparently I accidentally removed something. There we go. And here we go, CMD monkey. Now we have the entire monkey with the lighting effect that is set across the entire thing. I also, because I did 2 selections, I also have sort of a basic form of dithering. I did that on purpose. It's not great, but you can sort of do that kind of thing. Already, this is an extremely powerful technique for doing relatively complex shading this way, and with like World Edit or Axiom, you can do the rest very easily, right? You have this, and you can do the rest so easily, if that makes sense. Like you can just use this and then use use Axiom or World Edit to do the rest of the texturing if this is a little bit too much, for example. So here's one of the commands I like doing. So we can do gmask gray concrete. We can do replace below air. We're going to replace cyan terracotta. Is that the right thing? Yeah, there we go. So now anything facing upward is going to have a lighter color than anything facing downward. Obviously, there's a little bit of an issue with the fact that there's air on the inside of this, which is causing some issues. For the most part, that's not that big of a deal. We can actually just do hollow stone, right? So now it's stone on the inside, or at least it should be. Gmask hollow stone. There we go. Why is it not showing up? 1 second. Oh, there we go. It just turned hollow on the inside. Now whenever I do our replace cyan, replace below air, I forgot to set our gmask again, so it's going to be a bit of a mess. That's fine. Gmask, what was it again? It was gray concrete. Sorry for the lag. I forgot to do this correctly. There. And now we have a little bit more fancy texturing that way. that's like a bit nicer. We could obviously do, black concrete as well if we really wanted to. And we could say, uh, replace with, I don't really know anything better than black concrete. I think black concrete is the darkest, but we could change it to be something else. We could also just say maybe we want to replace black concrete with blue concrete or something, and replace above air black concrete, G mask blue concrete. There we go. A little bit weird. Still, the point that I'm trying to make is this is relatively advanced texturing that we were able to do based off of up, down, and one selection in Blender. And we have some relatively complex shapes on this monkey already just from doing that alone. Obviously, if you do fancier generators, you can do fancier things. So yeah, this is a very powerful technique to say the least. Now, obviously, there's even crazier stuff that you can do as well, including like animation. I guess I'll show animation. I don't really care to show animation. It's honestly not that complicated. It's the same thing. I guess it's cool though, so I will show it. So I guess we're just going to go here and just oops, that's not what I wanted. Go here and here, I guess. There we go. In this case, we're just going to set this, and we're going to set the location, insert keyframes. We're going to move it down the Y over here. Oops, that's not what I wanted. There we go. We're inserted keyframes. Delete keyframes because I didn't mean to do that. We're going to move it all the way back over to Y. And we're going to move this over here to what, like 120? Around there. There we go. Set our keyframes. We're also going to do a rotation at the end as well, might as well. We will need to set the transform, or set the origin to our geometry. There we go. Oops, slightly messed up. Should have set that down at the beginning. That's fine though. Sorry for this taking so long. This is not something I do very often. It doesn't really matter most of the time. We're also going to rotate a lot. Insert keyframes. And then here, we're also going to set the rotation to 0. And we're going to insert our keyframes. Very clearly, I forgot to set this further out. There we go. That's a decent amount of space. We're going to do our solidify. We're also going to do our remesh. We're going to do this as 0.5. We're going to do this as 0.7. Doesn't really matter how I do this. Looks like there's a relatively enough space because we need plenty of space to make sure it looks right. We're going to export as wavefront to OBJ. We're going to do, I guess I'll put it into cube over into here. We're just going to call this cube OBJ. We're going to apply modifiers, apply transforms. We're going to do the animation and go to 125. We're going to export all of the OBJs. We're going to go back to gen anim. Now with this one, how it works is we have the previous set of blocks and we have the current. Works the exact same way as the previous one. Literally, exact same way. Only difference is I compare the previous frame to the current frame. That's it. I'm going to run. I can't run it. I don't have my script at the top. So we're going to open up a terminal. In this one, I like to optimize it, so I'm going to compile it with optimizations. So we're gen anim d, and we're going to do release and dash o 3, some basic optimizations. Now I'm going to do gen anim .exe, and we'll run it. This will take a moment. Processing, and it's done. That's it. It just processed all of them. So now we go to CubeMC, and they're all right here. Those are all the separate frames. Now in this case, I actually have accidentally done this wrong. So one moment. Okay, I fixed it. I forgot to adjust something, but here we go. I gotta find the, oh, I accidentally killed the armor stand. That's nice. 1 second. Actually, I'll just show you how I do this. So I just summon the armor stand, and I'm going to give it a tag. I already have the tag set up. It's just right here, I believe. I'll just use this. So we can just tag, add anim. That will cause it to activate. Now whenever I set the timer back to 0, as you can see right there, it sort of gets clipped. That's because of how I have the animation set up from earlier. Because it starts underneath the ground, if you remember. So we go here, starts underneath the ground. It's very easy to fix something like that, right? Because we have control over the code. We don't have to make the code perfect. We don't have to make it work for everything. We can make it work for ourselves. So it's as easy as like, oh, plus 20, and it should work now. So if I just recompile and reload, it should work. Make sure that actually, yep, it runs, reload. And then now, set the animation. Now it looks like it mostly starts out correctly. Not entirely sure what's going on with part of it. Pretty cool though. As you can see, even cuts through this, which can be really cool for some animations as well. And it works live in-game, surprisingly fast. And the code is, yeah, 87 lines of code. That's a little bit longer, but still like not that bad. And I generated half of this with AI. That's one reason why it's sort of ugly. I didn't really care because I don't care to make this perfect. This is not a tutorial. This is just my workflow. I've written that code like 3 or 4 times. I would recommend if you're doing it for your first time that you do generate the not generate the code, that you do it yourself the first time. I do think it's important to learn how to do it yourself, but it's not necessarily required, right? It's simple enough. If you need the result immediately, yeah, generate the code with AI. I wouldn't recommend doing it for everything though. You need to know how to do it yourself. Why? So that you can do anything, right? In terms of this selection thing I did over here, I invented this idea while I was doing this tutorial. I thought, oh, I wonder if I could use that. And I decided to try it, and I used it, and I did it. Right? It was that easy. I did it within 15 minutes in the middle of like recording. I paused the recording, and I did it, and it worked, and I implemented it into this video the next day after discovering, this idea of using multiple objects for selections. I've done some similar things in the past, but nothing, that was a lot more convenient, where I used the name of the object as the material. Right? There's a lot of stuff that we can do along, these, this area. It's, like I said, surprisingly useful. We could also, instead of doing set blocks, we could do particles, right? That's another thing that, you might not necessarily realize. We can just take each of these and do them as particles instead. If they're particles, then that can also be super useful, because we could have that, animate that through time. Also, we could combine the object thing. We can take the object thing with the lighting, and we could adjust it over time, where we can have a selection or multiple objects that are moving across time of different materials. Now, we'd want the materials to be relatively basic, but if you set it up right, you could actually have a relatively complex model with multiple materials animated through time in a data pack live right there without mods. All I've showed you right here, everything so far. If we actually go to my mods page, look at that. I have world edit. I have nothing else. This is just basically vanilla Minecraft and like a little bit of world edit to speed things up. You don't even really need world edit when you're doing something like this. You can also do this with custom brushes. That animation right there, that's something where previously what I did was I took this, I commented it out, I set the replace, I did this tilde, I set it up like this. Oops, that's the wrong thing. I need to replace the tilde, or replace it with a caret. I set it up to be an animation where it does on anything that is called, that has the tag anim. So now if I do tag Mr. JCraft add anim, I do replace reload, sorry, not reload, and I do the scoreboard again. Unfortunately, it's going to be hard to see, but it's working off of my player position now, if I remember. Oh, wait, I need to regenerate because I forgot to do it based off the generation with this here, because there's also deleting blocks. We don't want to delete blocks right now. We're going to reload. Animation. Obviously, you'd want to adjust it, but now we have an animation going with our mouse controls as well. Now, for something like this, we'd actually not want it to be not want to use the animation one, because we want a full model every single time we place it, because currently it's placing hollow models, or like they're not connected, right? It's the animation, it's the optimization I did earlier. Still, the point remains, we just made an animated brush. That's another tool that I could make. We could do animated brushes that grow or shrink using scoreboards this way. And like I said, they are vanilla and effectively work on almost every version of Minecraft, works on even Bedrock Edition with almost no changes. The only thing you got to do is just make sure the data pack actually works on that version, because it's just a file. We could also, like I said, do this with schematics as well. We can generate schematics. We can do anything we want. Why? Because we are the ones in control, because we are the ones programming the code. We could decide what we want to do and how we want the code to work, because it's our code. That's what is so convenient about this. We can really do anything that we desire because it's our code, it's our models, it's what we want to do. In Blender, we can generate anything. We can take a rock or a model, we can rotate it. And that's the thing. Whenever you make something in Minecraft that is really large, like a 3D model or something, like this Suzanne head in this case, if I wanted to scale it up or down or rotate it, if I try rotating it in Minecraft, it will always have mistakes. It will always look a little bit off. But if I rotate or scale or do anything and I convert it from Blender into Minecraft, it will always look better compared to rotating it using a tool inside of the game. There's almost nothing you can do to fix that. The only thing that I could think of is maybe if there was like an AI tool that could rotate stuff correctly. That's about it. But that gets really complicated with fences and stairs and different building techniques, because you have to swap building techniques in order to get a build to look proper whenever you rotate it, especially with stairs and slabs and other stuff like that. Anyway, the point that I'm trying to get at is that this is an extremely powerful technique that requires very little code and only a little bit of knowledge. And just to sort of give you a little bit of a sneak peek of what you can do past this, I'm not really going to actually show you how to do this because it's a little bit too much, I think, for this video. But even skims are way simpler than people give them credit for. So if we actually just do, we have a sphere skim here, right? I'm going to copy and paste it real quick, like so, and we're going to rename. So we have our sphere 1.skim. We accidentally have 2 dots. That's fine. Now I'm going to take this. I want to use 7-zip. I'm going to extract here, and now I'm going to open up in Notepad. Right now we can see yellow concrete. If I actually take our sphere here and do skim load sphere paste -a, we can see this is the sphere that I was that's inside of that schematic. If I go back to our schematics, if I try to open up the schematic as .skim, it looks like gibberish. That's because it's compressed. We unzip it, now we can open it. If I actually open up a editor, we can actually see all the values a lot more obviously. So now if I go over to here and drag and drop this into ImHex, now we can actually view the model more properly. We have Minecraft yellow concrete. This is the number. It's 0. It's 1. So in this case, this is the value here. So the value is 1. If we actually scroll down, this is the Minecraft build. It's all these zeros, and boom, we get to our 1s. This is the sphere. All those 1s are the spheres. So this is one block. This is yellow concrete, yellow concrete, yellow concrete, yellow concrete. Each of these are yellow concrete. And this is the entire Minecraft build right here. So Minecraft yellow concrete 0001 or whatever, or just 1. Then this right here is all zeros. This is Minecraft air. Minecraft air is zeros. These are zeros. That's the air blocks. We have our yellow concrete right here. So that's also there. Then we have our block data. Our block data, this is the length of the block data. This is how many blocks we have. We have 1,000, 101,598 separate blocks inside of this here, which is relatively big if you think about it, but also sort of small considering. And it's because so much of it is air. That's one reason why, like when you do -a in world edit, it's faster because it's having to do less work because you're not pasting as many blocks in. It's still having to load them in though, of course. So this is all it really is. Like if we wanted to, I could take this and I could do, you know, O1. So if I take this and I just start pasting O1 everywhere, right, let me just do that. We're gonna take this, we're gonna paste, again, paste, we're gonna select it again, paste, oops, paste, select again, we're gonna grab this and we're gonna paste, select. This is going to look very strange. Actually, yeah, let's not do it that way. That's going to look very strange and it's going to be confusing, so let's not do that. There we go. Now I save it. I'm going to go back to this here. So we have sphere 1. Yeah, we need to delete this actually. So I'm going to open up this in the terminal. We're going to use gzip sphere 1. This will give us the thing that we need. Unfortunately, it's still open. There we go. We're going to overwrite it. Now we have sphere1.gzip. Now if I take this and I do .skim, there we are. Now we have that. If I do now my skim load on sphere 1 instead, and now if I paste it, what we'll see is that we have our line of blocks. Now you're probably wondering, wait, what? This is not really that much of a line. It looks a little bit different. 1, 2, 3, 4, 5, 6, 7. If we go inside of our editor here, it's going to be a lot more obvious once I actually show what it looks like inside of here. So we have 1, 2, 3, 4, 5, 6, 7. Then we have 1, 2, 3, 4, 5, 6, 7, 8. The other 8 are down over here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 7 and 8, they're literally right here. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. Right? They're all right here. So this would be our 15 or 16 blocks or whatever. I did not count correctly, but that's fine. The point is, that's it. I just modified a Minecraft build, a schematic. I modified a schematic inside of a hex editor, I could modify inside of a text editor if I really wanted to, and was able to modify it, change the output, all from just typing in a couple of numbers, and that is it. We could even like swap out blocks if I really wanted to. We could do almost anything with that. We could generate our own skim if I really wanted to, right? The file's really not that complicated. As I just showed, I can modify it live. I didn't even plan to do that. That's how simple it is. I was so confident I could do that with relative ease. I didn't plan on doing that. That was spontaneous. That is how easy it is to do modifications like that. That is basically it for this this video. If you have questions or comments or concerns or whatever, go to the Discord server or the comments down below. Obviously, if you comment, this video will get more views, which is really good. So please comment as well to encourage the algorithm to actually send this out to people. And share it with your friends if you think that they will appreciate something like this. I want to know if people actually want to do stuff like this, because this is one of the reasons why I don't do YouTube videos anymore. I build stuff like this and do crazy shenanigans with Minecraft that just don't seem like they'd be popular. I don't think people would want to watch videos on this, so I just don't do videos on them. So yeah, go to my Discord server and try to harass me into doing these videos if you think they're going to be of actual use. Anyway, that's basically it. Have a great, wonderful, sublime day, and God bless.